Okay, here we are filming the answer key for the practice quiz. Pause me because I'm going to go pretty fast, otherwise this will take too long. We are looking at the definition method of finding this derivative at a fixed point. So I'm going to use the straightforward method with a fixed point. This is more the 2.6 version of this problem. So the definition is based on the idea of the limit as x approaches that fixed point. In this case it's 2, and then it's f of x, which is 3x squared minus 7, then minus f of 2, which is 5, all over x minus 2. Okay, and of course I can't plug in 2 because I get 0 in the denominator, so I got to do some fancy algebra to make this all work, and we know that it is always going to work because that is the way it is in this sort of problem. So I've got 3x squared minus 12 all over x minus 2. Okay, well, you know it's going to work. You can either factor it, in which case it's going to be the limit as x goes to 2 of 3 times x squared minus 4 all over x minus 2. And this then can factor to be the limit as x goes to 2 of 3 times x plus 2 and x minus 2 all over, guess what, x minus 2. So maybe you didn't realize that this is going to factor so nicely, and that's the difference of two squares. So if you want to, you can do it polynomial long division. I'll do that in a second, but the answer is coming close. It's going to be 3 times x plus 2. Now we can plug 2 right in there. It doesn't give us division by 0. 2 plus 2 is 4 times 3 is 12. So to find the equation then, all I need is a slope, which I've got. That's the definition of our derivative, that it's the slope of a line of tangency. And there's our point, so it's going to be y minus 5 equals 12 times, in parentheses, x minus 2. Don't forget to put it in parentheses. There you go. If you didn't know to factor and you just wanted to go through polynomial long division, you can certainly do that. X minus 2 out there. Just remember you write 3x squared and then plus 0x and then minus 12. You need this space holder there. And then you ask yourself, what do you multiply x by to get 3x squared? Well, that's 3x. When you bring that into both of those, you get 3x squared and then minus 6x. And you can subtract, or I think it's better to change the sign and add. That's the same as subtraction. You get 6x, bring down the minus 12, do the same thing. I multiply by plus 6 to get my 6x, and then it's minus 12, and I change the signs and add, and it always should work out to be 0. That's the same thing. 3x plus 6 is the same thing here as 3 times x plus 2, and you'll get the same correct answer. Moving right along, now I've got an equation method, and I'm going to find the general derivative. That's using a, and that comes from taking the limit as h approaches 0 of f of a plus h. So that's going to be the square root of a plus h squared plus 1, and then minus the square root of a squared plus 1 all over just h. Okay, so that's f of a plus h minus f of a all over h. So now I just have to grind through the algebra. When you've got radicals, you have to do the conjugate. All right, so if I'm going to call this, just for short, as a shortcut, the long radical and then the short radical, because that extra h. So I'm going to multiply this by its conjugate, which is the long radical plus the short radical, all over the exact same thing, long radical plus the short radical. And I know to get to the next step then, I'm just going to FOIL that out, but you get wonderful cancellation things happen in the rainbow bits. These guys are going to drop out. So I just get a plus h squared plus 1 minus, and then a squared plus 1 grouped in parentheses, because that radical is a grouping symbol. So then the middle bits with the radicals cancel out, and then down below I get h times and I'm just going to keep the long radical plus the short radical. You have my permission to do that if you want. Just saves a lot of extra writing. You have to be really clear that this is the long radical bit and that's the short radical bit. Now I'm going to FOIL out this part at the top, and I get the limit as h goes to 0 of a squared plus 2ah plus h squared plus 1 minus a squared, and then I'm bringing in that minus sign to both, and I get minus 1 all over h times long radical plus the short radical. Alright, well this is like up above where you know it's going to factor. Here I know things are going to cancel. The a squareds cancel, and then the plus 1 and the minus 1s cancel. And then I get the limit as h goes to 0 of 2ah plus h squared all over h times, and here I'm going to write the long radical because now is when I need it, a plus h in parentheses squared plus 1, and then plus the square root of a squared plus h, and that's in brackets or bigger parentheses. Well, now this h is always going to cancel. That's the problem from before. I can't just plug in 0 because I get 0 in the denominator, but now it does cancel, and I can let this go to 0. So as h goes to 0, I get the square root of a squared plus 1 in the denominator now, plus h goes to 0, that's a squared plus 1. I wrote h, that's just a little, that's a plus 1. I get the square root of a squared plus 1, and that's all underneath 2a, because the h cancels and it's not there anymore, and here this h only one cancels, and when h goes to 0 it goes to 0. So this is my final formula, and I'm basically done with that. That is the derivative. So you write g prime of a is equal to that. That's the derivative. Alright, well what happens now? We're going to use that to find when x is 0. So g prime of 0, plug in 0 and you get 0 in the numerator all over the square root of 1 plus 1. So that's equal to 0 over 1 plus 1 equals 0. When I plug in 3, g prime of 3 is going to be equal to 6 over, and then when I plug in 3 I get 9 plus 1 is 10. Square root of 10 plus the square root of 10 is equal to 6 over 2 radical 10. And you don't have to rationalize it if you want to. That's equal to multiplying by top and bottom by radical 10. You're going to get 6 radical 10 all over 20, and that's equal to 3 radical 10 over 10. But this is okay. And then finally, g prime of radical 15, when I plug this in, I'm going to get 2 radical 15 all over. Squaring radical 15 gives me 15 plus 1 is 16. I take the square root of 16 and I get 4 plus 4. So that equals 2 radical 15 over 8, which equals radical 15 over 4. And so either of these are okay. Alright, there you go. Good luck.